The only way to obtain exact metric dimensions of available vertical bone substance is by radiometric means. To circumvent the imprecise magnification factor of 1.2 to 1.4, radiographic examination is performed with a custom-made deep-drawn measuring template featuring metal balls. These metal balls are 5 mm in diameter and serve as reference in the X-ray. The sharp silhouette on the radiograph supplies the reference value for the magnification factor. In this way, the dimensions of available vertical bone can be evaluated very precisely using the formula 5 mm as the material diameter of the reference ball multiplied by the vertical distance of the alveolar ridge to the inferior alveolar nerve as reflected in the radiograph, divided by the diameter of the ball as reflected in the radiograph. In our specific example, this means 5 mm as the material diameter of the reference ball multiplied by 18 mm as the vertical distance obtained on the radiograph, divided by 6 mm as the radiographic diameter of the reference ball. Consequently, vertical bone distance is 15 mm. This calculated value should not, however, be understood as being equivalent to the length of the implant, since the tip of the drill exceeds the insertion depth of the implant by 0.4 mm. It is therefore necessary to keep a safety distance of 1 to 2 mm from anatomically critical structures like the maxillary sinus or the mandibular canal. Conventional radiographic techniques for metric determination of jaw width, such as side-view teleradiography, as shown here, are only useful in the center of the jaw. Hence, transversal bone availability has to be determined clinically by measuring the thickness of the oral and vestibular mucosa. The values obtained are then subtracted from the total width of the alveolar crest. The thickness of the mucosa is best measured in mucosal anesthesia using a dental probe with a movable silicone stop guide pushed over its tip. In this way, the alveolar process is sampled at several sites. The values obtained are transferred to a saw-cut model for bone mapping, which results in a rather faithful cross-section of jaw width. These data provide a good basis for anticipating the diameter and axis of the implant.